closing the system. This is a very important topic because it is what technology does. But it is also what bureaucracy and dictatorship does. Closing the system is a way to make it more predictable and controllable, but also less vibrant and lively. It characterizes many school systems, company, the military, fundamentalistic religions, and in fact everything governed by the coping mode. So let's first go into the difference between controlled and innate dynamics.
The left picture we have an electronic circuit board, and the right picture we have a so-called Kalman vortex street that emerges when, in this case, you float soap on water and have it meet an obstacle. And here is the obstacle. So down here, that's the obstacles. And behind the obstacle we have all kinds of forms, and the forms they are similar, but they are never completely the same. So here we have all kinds of regular structures that are static, they allow precise precisions, and many patterns are repeated. And here we have, well, irregular structures, although they are similar. They are dynamic, they are not well predictable, at least not very well, and every pattern is unique, while here many patterns are repeated. And this is kind of an ideal difference between controlled and innate dynamics. Another example is just this. This is a shaped environment here of a city versus something that was allowed to self-develop, nature, and with exactly the same properties. So more irregular structures, it's dynamic, it's less precisely predictable, and every pattern is unique. Although all kinds of things are more or less repeated, and we have structures that are repeated, but not in the way this is structured. It's a completely higher level of control over the situation. So let's go into, so let's start with a general system. A system that has innate dynamics, and it has influences on it, and it exerts influences to the outside. The key of the definitional properties of a system is that it has stronger internal relations than external relations, and it has innate properties and dynamics that are characteristic. So we can go in two ways. We can control the environment and hence curtail the innate dynamics, or we can liberate it from limitations and therefore promote its innate properties and its innate dynamics. So, and we focus on the left, on controlling the environment. So let's close the system here, and we do that by imposing more and more conditions on what the system can have as an input, and that leads to the closing of the system and more predictable dynamics, and with that a predictable output. So that leads then to a closed system defined by the conditions imposed on it. And who imposes the conditions on it? Well, that is the agency. That is what agents do. They do it to create their own environment of the cell and what makes them living, but they also can impose limitations and conditions on things in their environment. So closing a system is an act of agency, and they do that by controlling the environment of a system, and hence they ensure that the system can be approximated as isolated from the rest of reality, because whatever relationship they have with reality is under their control. And they do that to create a predictable or dependable utility, typically. So agents shape the world by closing systems around them or closing themselves, and therefore making the world more and more predictable. At least that is one strategy. So let's go to a highly controlled system as an example, the smartphone. So the smartphone is designed to let electrons do exactly what they need to do, and that corresponds to all kinds of behaviors that we then interpret as a useful function. So you press a number of buttons or places on the screen actually. And then some information is fetched from somewhere around the world, ferried back, presented in form that we understand. And this is all electrons moving. And in between a little bit of electromagnetic waves. But this whole process is completely under control. And that leads to a super special and dependable organization. That is actually, it's super unique that we are able to make this. And no single person can make this. This can only be made by many thousands of people working together, because no one is able to make an iPhone from scratch and first principles. That's way beyond our individual capability. So let's go into a number of properties of, in general, controlled systems. Well, like the smartphone, they have a predictable utility. And they originate from high-stake problem solving. That's the whole purpose of closing systems and the coping mode in general. Therefore it works in familiar situations. We create a system for a particular situation, and that situation must be familiar, although it might be a problem. It is always a short-term view, so it's if this, then that. And that's the general thing of a closed system. And depending on the time scales of the system, it is always not more than this. We have created a system with a known and finite set of inputs, internal states and outputs. And so it's all known and finite. Well, it's not completely finite, but it's well enough. And because we closed it from its environment, it is unaware of its environment. And going to the other side again, because it was originated in high-stake problem solving, it is about one solution, the solution that we take. And that solution, that can be realized when we ensure that the conditions on which the solution depends are true or false, and it must be true eventually. That is the power part. We have to make the conditions true, influence the environment. But it means that we have a class of situations in the world for which the conditions are true, and another class for which the condition is false. So we have a binary classification. Either we are interested in either whether they are true or whether they are false, and whether they are false we want to make them true. And that also means that we are not so interested in what is the particular situation. We are only we want to know whether it is this class or that class, and we are insensitive to within class differences. We are actually only interested in categories of things, not individual things. And we are only interested in useful categories that help us make those conditions true or false. So this is already saying a lot about how our rationality works. And models of artificial intelligence have these components. And it is not for nothing that it's also part of an iPhone. But we can make this a little bit more complicated. We can have a system as part of a nested system in which those systems collaborate with other systems in all kinds of convoluted ways, but there still is something of an input and a predictable system function and an output. And now you see that the order and structure is very important. So if you screw around within this system, then the system will not work anymore. And that has associated with syntax, with form. Another thing is that this system with its function has observable effects, and whoever is observing it, it will see something similar. And therefore we have a system of shareable objective meaning. Everyone kind of agrees on what this system is doing. And we have parts that lead to the whole. So it's constructed from the bottom up. Isolating the system itself also has a number of consequences. So we have a focus of attention that makes sense. So this system is actually part of a much bigger whole in which we focus on this part. And that means that we ignore or suppress other parts. And others are distractors, but some are kind of interfering with our ideal system function and our ideal focus of attention, and they don't contribute really to it. And the easiest way to deal with them is to deny them. And you have to deny those influences in some way to keep the system function. So it is very similar. If you have your bureaucracy and the bureaucracy works according to this form well filled in and then leads to that action. And then someone all of a sudden says, yes, but your sister, it's not on the form. So it doesn't matter what your sister. And so these are all kinds of influences that a bureaucracy has to deny, basically, because it doesn't help to contribute its function. We can make this even more complicated, and this is a picture of cellular processes, a so-called metabolic metro map. And this is how our cells, as the closed system, have a very similar structure of all kinds of relationships that lead to different functions. So a key function here, for example, is the citric acid cycle that is in energy production. And this is about carbon fixation and photorespiration, which plants do. So not every part is present in all cells, but in general, pretty much all metabolics of life are presented in this picture. So now we have a few more properties that I added to this picture. And these are properties that in general say a lot about how closed systems work. So how about opening a system? And I will talk about that later, but a little bit now. So opening a system is another process. It's changing an okay system into a better system. And that also is an act of agency. And it is an act of agency because agents then allow the system, either other agents or whatever, to discover its innate dynamics, also still embedded in the environment. So it is about releasing systems from imposed constraints, and so to allow full self-development. And this is the picture that you would then expect: full self-development given an environment. And so this is not an environment in which so much is living, but in all kinds of places where something can live, there is something.